In this document, I've outlined some useful trigonometric properties that we've become familiar with over the last week or so. So just a reminder of what the unit circle looks at with its origin and its radius of 1 unit. We know that the equation of the unit circle is given by the general form of the equation of the circle, where x squared plus y squared is equal to 1. And we spoke a little bit about how changing the center of the circle and how changing the radii affects the general form of a circle. Then we know that any point along the circumference of the unit circle, and the x-coordinate can be given by cos theta and the y-coordinate can be given by sine theta. So if we substitute those values into our equation for a unit circle, we can derive the property that cos squared theta plus sine squared theta is equal to 1, and this identity will be used often throughout coming lessons. We know that cos theta and sine theta are valid for all values greater than or equal to -1 and less than or equal to 1. We then spoke about the periodicity of trigonometric ratios, so I won't go over this in detail because I did in a previous lesson, but now this should be familiar to us and we can see how the cosine and sine and tangent functions take the same values as we move around the unit circle. And then finally, in yesterday's lesson, there was a number of properties that we derived, which some of them you've actually seen in the past. So for example, when we looked at the ambiguous case, you would remember that we had already mentioned that sine of 180 minus theta is equal to sine theta, and we used that to find multiple angles. Now, through the investigation, or through yesterday's question and that investigation through the questions, we would have seen why these properties actually made sense. So these are properties that you'll be able to apply and you'll need to apply as we continue to work through the chapter. Okay, so we're going to move on to 5D, applications of the unit circle. So in example 7, we're asked to find the possible exact values. We don't want approximate values, we want exact values of cos theta if sine theta is equal to 2 over 3, or 2/3. So let's go through this example. So let's start off with our identity that we have discussed. So from the equation of the unit circle, we know that we can say that cos squared theta plus sine squared theta is equal to 1. Then if we are to substitute our value of sine theta into this, so you can see that the cos squared theta stays as is, and I substitute 2/3 in for sine theta. So, but this wasn't sine theta, it was sine theta squared. So we substitute the 2/3 in. Then we know that if I want to isolate the cos term, basically I need to subtract that value from both sides. So, and I mean, you could do this. You could square 2/3 and then subtract it from both sides, but they've subtracted it from both sides and then they'll simplify. So then we can see that cos squared theta is equal to 5/9. Then I'm not interested in cos squared theta, I'm interested in cos theta. So if I take the square root of both sides, you can see that, and remember they want an exact form. So if I take the square root of top and bottom, then I'll get square root of 5 over 3. And notice that it's the plus or minus. Now, in terms of the unit circle, let's consider why it would be plus or minus. So when we're dealing with cos theta, we're dealing with the x value. So let's first consider the positive value of the square root of 5 over 3. We know that it would be at this position here. So cos is equal to square root. You can see that when it's equal to the square root of 5 over 3, that the sine value is 2/3. What about when it's negative square root of 5 over 3? Well, again, you can see that when x is, or the cos value is negative square root of 5 over 3, that our sine value is going to be equal to 2/3. Okay, in example 8, we're asked to do something similar. So they give us a value of sine theta as -3 over 4, and they'd like us to find cos or tan theta. However, we have this extra condition that the value of theta has to be between pi and 3 pi on 2. So let's look. We are going to start off with that same identity, that cos squared theta plus sine squared theta is equal to 1. We're going to substitute this value of sine theta into our equation. Once we substitute that in, we have to square it. So minus 3 over 4 is going to become 9 over 16. Then we're going to rearrange the equation to try and isolate the cos term. So if I subtract 9 over 16 from both sides of the equation, I'm left with 7 over 16. Then to get cos theta by itself, I need to take the square root of both sides. So you can see I take the square root of 7 and the square root of 16 is 4, and we're interested in the positive or negative value. But this is where this condition is important. So we're only interested in values of theta between pi and 3 pi on 2. So where does that happen in our unit circle? Well, here is pi. Here is 3 pi on 2, so it has to be in this third quadrant. So if we consider this quadrant here, then we know that the value of cos theta, which is our x, which is given by negative square root of 7 over 4. So let me just drag this along. So we can see that for our sine value of negative 3 over 4, that our x value or our cos value is going to be negative square root of 7 over 4, not the positive one, because the positive case would be in the fourth quadrant, but we're only interested in anything in the third quadrant because of this condition that's been given. Then they also asked us to find tan. We know that tan theta is the same as sine theta over cos theta. So let's just substitute in those values. We've got one fraction over another. When we have something like this, we can flip the numerator and the denominator to make this a multiplication. So this ends up being the 3 over the square root of 7. So just in case you're unfamiliar with how to do this, I'll quickly show you. So I've got tan theta is equal to sine theta over cos theta. So we substituted in our value for sine theta and cos theta. Now, since this is a division, what this can be written as, I can leave the minus 3 over 4 as is. Now, I don't want this to be a division, I want it to be a multiplication. So what I can do is I can turn this into a multiplication problem by flipping this numerator and denominator. So that could actually be written as minus 4 over square root of 7. And then what we can do is those cancel out. That's a minus, that's a minus. So I'm going to be left with a positive result, and it's going to be 3 over square root of 7. See, that's how they've determined that tan theta is going to be 3 over square root of 7, and we know that it's the one in the correct quadrant because we use the relevant cos theta term. Okay, let's have a look at example 9. So this time they've told us that tan theta is equal to negative 2. We're interested in a range of thetas between 3.5 pi and 2 pi, so that's in quadrant 4, and we're asked to find sine and cos. So this is going to be slightly different. We're not going to start off with the identity that we started off with last time. This time we're going to start off with
multiply
tan theta is equal to sine theta over cosine of theta. And we know that tan theta is equal to negative 2. All right, so far so good. Then what we can do is we can now we're just interested in this bit here. So sine theta over cos theta is equal to negative 2. If I multiply both sides by cos theta, then we will get sine theta is equal to minus 2 cos theta. Then now we can apply or we can use something that's a little bit useful. So we know that this identity, sine squared theta plus cos squared theta is equal to 1. We just came up with something for sine of theta, which was minus 2 cos theta. So let's substitute this into that identity. So there we go, we've substituted that in, and now we can simplify. So I've squared the minus 2 to get the 4, and I've squared cos theta to get cos squared theta. and I've got another cos squared theta. Now look at this. I've got 4 cos squared thetas plus another cos squared theta. So I've got 5 cos squared thetas is equal to 1. If I divide both sides by 5, then I would have cos squared theta is equal to 1 over 5. And then if I take the square root of both sides, then I'd be left with 1 over square root of 5, plus or minus. But we're only interested in values in this range. So this is going to be in quadrant 4, in quadrant 4, which means that the cos value, the x values have to be positive. So we're only interested in the positive value. So that is going to be cos theta is going to be positive in this quadrant, and sine of theta is going to be negative. So we know that our cos value is going to be 1 over square root of 5. And look at this. Well, we know that sine theta is equal to minus 2 cos theta. So let's substitute the value of cos theta into this, so then we can find our value of sine theta. So sine theta is going to be minus 2 times 1 over square root of 5, which gives us minus 2 over the square root of 5.